For this particular topic, we're going to focus on first-order non-separable differential equations. In other words, all our examples here are of exponent 1. Now, for you to understand the word non-separable, I'd like you to focus on the two groups of examples, the ones written in red and the ones written in black. So the one we usually find integral with is the one written in red, whereas the one written in black are usually mistaken as something similar to the ones in red, but the truth is they're not the same. Now, if you try to look closely, the ones in black is like integral of x plus dx. In this case, we cannot say integral of x with respect to dx because they are two separate expressions. In other words, we are finding the integral of the variable x or of the variable y squared without any reference to. Now, comparing it to the one in the left, here it's integral of the expression x plus 1 with respect to dx, meaning we're trying to find the integral of this with respect to this variable x. In other words, this is the one that we can find an integral with, whereas this is something that we cannot directly find its integral. That is why we call these non-separable. Now, there are differential equations that look like this, and an example of which is this one. Suppose we have the derivative of y with respect to x equal to this particular expression. So if you try to look at it, if you try to manipulate this one so that this will go closer or next to your y prime, for example, you might see that this will have an operation of plus. So it's like dy, for example, over dx plus 2y, by which they are two separate things. In other words, this particular differential equation cannot be separated such that we form something with respect to dy and another thing with respect to x. All right? Since we cannot do the usual thing we have done last week, this time we are going to solve it in a non-separable way. Okay? And how do we do that? First thing, for you to be able to solve a non-separable differential equations, you have to write it in this form. Y prime plus an expression of x times y. So this expression is that expression of x which contains the y, or the expression itself which contains the variable y, if this is y prime. So this may be a number only, or this may be an expression, which you will see later on, equal to another expression solely for x. All right? So in this case, for us to write this in this particular format, so we have to transfer the 2y to the left side. Thus, we will get this. So this is now what I'm telling, that this p of xy is the expression, is the term which contains the variable y. And the coefficient 2, or whatever coefficient is found beside the y, is your p of x. Alright? So therefore, in this form, we can now conclude that your p of x is equal to 2, which is the one beside the y, and your q of x would be the one left at the right side, which is 2e power of x. Alright? So these two things are very important. Now, what's left would be the I of x. Now, what do you mean by I of x? I of x is what we call as the integrating factor. And I of x is equal to e raised to the power of integral of your p of x dx. Alright? Which in this case, it may look quite complicated in a form, but honestly, when you do the integration, it isn't. So if we try to substitute e raised to the power of integral of your p of x is 2 with respect to dx. So see, it's 2 with respect to dx. There's no plus sign in between them. So we can now proceed at integrating this. This becomes e raised to the power of 2x. This is now your integrating factor. And these three things are the things that we need to know. You may pause this video and copy down notes if necessary. So how do we now solve this differential equation? So this differential equation will just be equal to, this is now the formula, or this is now the form, 1 over the integrating factor times the integral of the product of the integrating factor and that q of x with respect to dx plus your constant c. So if you put it in all together, substituting it, we'll get this. And of course, we can actually simplify them because the bases are the same. E power of 2x and e power of x. So if the bases are the same, according to exponent law, we can just add the exponents. So we can now simplify this as such, and we can now proceed at integrating it. But since this is a constant, we can just put this outside. All right? So right now, we are integrating e power of 3x with respect to dx. Recall your laws of integration. So we now have 1 over e to the power of 2x times, take note, this will be 1 over 3, 1/3, because of this exponent 3. So 1/3 of 1/3 of e power of 3x. But since you have a 2 here, so we can just multiply this to your 1/3, thus you will get this one. So this is already the simplified form after you're integrating this. So there are some steps here which are skipped and which are assumed that you already know how to do. All right? So if you try to simplify further, if you try to multiply, so this now becomes this expression. And since we have the same base, we can just simply apply exponent law, by which it says if you are dividing, subtract the exponents. Thus we get 2/3 of e to the x plus c, the constant. And usually we put these things on top. So we say e to the power of negative 2x. Putting this on top makes your exponent negative. All right? So this is now your general equation. However, if you are given conditions, example, that y equals 8 when x equal to 0, you can proceed at finding the value of c in order to get the particular solution. So solving for the c, substitute the values given. Thus you will get c equal to 12. So when you substitute 8 here to the y and 0 here to the x, solving it gives you a c equal to 12. So from there, you can now find or write your particular solution. All right, and this is how we solve non-separable differential equations. Now, how do you know if this is correct? So recall that this is the given and this is the solution. All right, so how do you verify that this is correct? We can actually verify it by substituting this in the original equation. However, for us to verify further, we also need the value of y prime. So to make it a little simple, we can just rewrite this in a way saying that your y prime, if we put this to the left, plus 2 times the y should be equal to the expression 2e raised to x. To be honest with you, you don't have to manipulate it. But in my case, I wanted to manipulate this to the left side so that all the y's will be found here. And so I just need to prove that when I substitute my y and substitute my y prime, simplifying it gives me this particular expression. Because later on, we need to find your derivative of this. And whatever derivative we get, substitute it here. And this expression for y, substitute it here as well. Simplifying it, we should get this. All right? So again, we need to find your y prime, and y prime would give you this. So I expect that you know already how to get your derivatives. So once you have these values or these expressions here, you can just substitute this expression to the y and this expression to the y prime. Thus, you will get this. Pause this video and try to study further. All right? So just simplify. Okay? And here you can see opposite operations. So you can just cancel it, make it 0. So what's left would be this. And then when you combine them, combine the fractions, you will get this one. Simplifying it, you'll get this. Therefore, the two equations are equal, telling us that this answer indeed is correct. And this is how to check if your answer is correct or not. All right? Let's have another example. How about this one? So how do we solve this differential equation? You may pause this video and try this on your seats. All right? So again, we just have to manipulate it so that we can write it in this form. Okay? And manipulating it, we can divide all terms by x minus 2. Thus, we will get this. So from here onwards, we now have written the given into the form prescribed. Wherein your p of x. Oh, by the way, before we proceed, we can simplify this further by factorizing, canceling this out, so we'll have a much simpler expression. From here, we can now find our p of x, which is the one beside the y, 1 over x minus 2, and your q of x as x plus 2, the one at the right. Observe. This is now the function of x, or with respect to x. Okay, so what we need now will just be your integrating factor. So integrating factor will just be e raised to the power of p of x. Your p of x is this. Substitute it, all right? And using your laws of integration, you can, when you simplify this one, this will just give you ln x minus 2. By the way, here in the integrating factor, you don't have to write plus c, okay? And laws of logarithm, if you have this particular form, e raised to a certain ln, this will just be equal to x minus 2. All right. Now, since we already have the integrating factor, we can now solve this differential equation using this format, and we only have to substitute our expressions here: integrating factor and the q of x. All right. So when we do substitute and when we do simplify, so here for us to find the integral, it's better to simplify so that we'll get this. And from here onwards, it's now quite familiar on how to simplify or to integrate this. Okay, so if we continue, we ended up with this. So finding the integral of the one inside here, you will get x cubed over 3 for the first term and negative 4x for the second term. Then you have plus c. Okay, multiplying this, you will get x cubed over 3 times x minus 2. Multiplying this to the second one, you'll get minus 4x over x minus 2. And of course, multiplying this to the last one, you will get c over x minus 2, by which we just have to put it on top. So putting it on top, the entire expression will have an exponent of negative 1. Okay, so this is now what we call as the general solution. Again, if you're given certain conditions, say for example this one, you can just simply substitute this to your x and to your y here to solve for c. In this case, the value of your c is actually equal to 6. So once you get the 6, then you can substitute it to the general to get the particular solution. Now, I'm not showing that anymore because we have done that in our discussion last week. So you can just do the same thing in order to find the value of c. All right. Now, for this afternoon, I'd like you to answer all these 4 items. This is the item I've shown you at the beginning. Try to do it again. And once you're done with the first one, try to look at the answer key. So when you click on this, you will see the answer keys. All right. So once you're done with number 1, you can now click and see the answer. Then proceed to number 2. Once you're done with 2, and then proceed to 3, same thing, and number 4. So make sure you look at the answers only right after you attempt to solve each item. All right, thank you so much, everyone.